Every permission in AWS gets evaluated the same way, and by default, the answer is always no. Every single request starts denied. That's not a bug, that's the entire design. AWS IAM, Identity and Access Management, is the system that controls who can do what inside your AWS account. Every action, whether it's launching a server, reading a file, or deleting a database, goes through IAM first. Think of it like a building with a security desk at every door, not just the front entrance. Your badge doesn't just get you into the building. It has to specify exactly which rooms you're allowed in, which drawers you can open, and whether you're allowed to take anything out. No badge? Every door stays locked. That's IAM. IAM is the foundation of cloud security. Get it wrong, and the consequences aren't hypothetical. They're headlines. In 2019, a misconfigured IAM role exposed over 100 million Capital One customer records. The role had far more access than it needed. That's not a rare edge case. That's the most common class of cloud breach, an identity with permissions it was never supposed to have. On the flip side, teams lock things down too tightly and then spend hours debugging why their application can't read from S3, only to find the IAM policy was missing one line. Whether you're studying for your AWS certification, building a startup, or managing infrastructure at scale, IAM is the thing you touch constantly and the thing most people only half understand. IAM has 4 building blocks worth understanding clearly: users, groups, roles, and policies. A user is an identity tied to a specific person or application. A group is just a collection of users. You attach permissions to the group and everyone in it inherits them. Clean and simple. Roles are where it gets interesting. A role isn't assigned to a person permanently. It's assumed temporarily by a service, an application, or even another AWS account. When an EC2 instance, that's a virtual server, needs to read from an S3 bucket, that's cloud file storage, you don't give it a username and password. You attach a role. The instance assumes that role, gets short-lived credentials automatically, and those credentials expire on their own. That's far safer than storing a static password somewhere in your code. Policies are the actual permission documents. They're written in JSON, a structured text format, and they follow a consistent pattern: effect, action, resource. Effect is either allow or deny. Action is what you're permitting, like S3 getObject, which means reading a file from S3. Resource is the specific thing that rule applies to: a particular bucket, a specific function, or a wildcard if you want it broader. Here's the key evaluation logic. If no policy explicitly allows something, it's denied. If there's an explicit deny anywhere, that overrides everything, even an allow somewhere else. Explicit denies always win. And if this is the kind of thing you want to actually understand, not just memorize for an exam, Stack Future covers one concept like this every week. Say you deploy a Lambda function, AWS's serverless compute service, and it needs to write logs to CloudWatch and read configuration values from SSM parameter store. You run it and immediately get an error. Access denied exception. User is not authorized to perform SSM get parameter. The fix isn't complicated once you understand IAM. You create a policy with 2 statements. The first allows the action logs, create log group, and logs put log events on your CloudWatch log group. The second allows SSM get parameter on the specific parameter path your function needs. Something like ARN AUS SSM US East 1 123 7802 parameter mayapi peak config. Then you attach that policy to an IAM role and attach that role to your Lambda function. The function assumes the role at runtime, gets exactly the permissions it needs, nothing more. That principle, least privilege granting only what's necessary, is the habit that separates good cloud architecture from the kind that ends up in a breach report. IAM isn't a checkbox. It's a decision you're making about every identity in your system and exactly what it can touch. Remember the model: default deny, explicit allow, and explicit deny always wins. Get that logic in your head and most IAM problems start to make sense. Next up, what is RAG and why should you care? Retrieval augmented generation explained clearly without the hype. If this clicked for you, hit the like button. It genuinely helps more people find this content.